Welcome back to our channel. In today's video, we'll explore some special types of matrices. These matrices are important because they have unique properties that make them useful in various mathematical and real-world applications. Let's dive in.
Let's start with nilpotent matrices. A nilpotent matrix is a square matrix that, when raised to some power, becomes a zero matrix. In simpler terms, multiplying the matrix by itself repeatedly eventually results in a matrix full of zeros. For instance, let's take a look at this matrix N. If we square N, we get the 2 by 2 zero matrix. Here's another example. This matrix is also nilpotent because if we square it, we get the 2 by 2 zero matrix. Next up, diagonal matrices. A diagonal matrix is a square matrix where all of the elements outside the leading diagonal are zero. Here we have a diagonal matrix D. Notice that the only non-zero elements are along the diagonal, in this case, 4 and -2. Here's a larger example. You can see that the diagonal elements are 10, 5, and 8, and everything else is 0. Diagonal matrices are important because they're easy to work with in operations like matrix powers and diagonalization. Now let's talk about triangular matrices. Triangular matrices are also square matrices, but they have a specific structure. There are two types, lower triangular and upper triangular matrices. This is a lower triangular matrix where all the elements above the diagonal are 0. Notice how the upper right triangle is filled with zeros, leaving the diagonal and lower left part filled with non-zero elements. This is an upper triangular matrix where all the elements below the diagonal are 0. Here, the bottom left triangle is filled with zeros. Triangular matrices are especially useful in solving systems of linear equations and are easier to work with in matrix decomposition techniques like LU decomposition.
Let's quickly recap. We covered nilpotent matrices, which become 0 when raised to a certain power. Then we looked at diagonal matrices, where only the diagonal elements are non-zero. Finally, we explored triangular matrices, which are either lower or upper triangular, depending on where the zeros are located. Now, it's your turn. Try practicing these operations with your own matrices. Check the description for some example problems and let us know how you did in the comments below. That's all for today. If you found this video helpful, don't forget to like, comment, and subscribe. Also, if you have any questions or want us to dive deeper